Binary operation table. So binary operations are what? Bi means 2. So there will be 2 values, or we can call it as operands. There will be some operation inside it, that is plus, minus, division and multiplication. So you have value A from set capital A, value B from capital set A, and when we operate, you are getting a value which also has to belong to that same set. That is the binary operation. So this binary operation table is a visual representation of a set where all the elements are shown along with the performed binary operation. This can be any binary operation. So you can perceive it's visually very overwhelming. You can easily see what is happening where, rather than writing one by one line. So here we have a set. For example, we are taking set as 1, 2, 3, 4, 5. This is our set which we will be discussing. And there will be an operation. You can call it as a star, you can call it as O, you can call it as a cap. So we are taking the operation as cap. So when we are trying to represent a binary operation as binary operation table, so how do we write? This cap, which is actually operation, is such that S cross S, that is the first element is going from this set, second element is all going to come from this set, and there will be an operation on this set, and the result is going to be from the same set, S. So we are calling a table because we have the rows. The direction I'm showing is the direction of the rows, and the vertical lines or vertical say bars, these are called as the column, the horizontal rows, vertical columns. So A cap B is what we are representing. A can be 1 to 5, B can be 1 to 5. For example, let us take an example. This 3. Okay, we have 3, and let us take from here 4. So 1, 2, 3, 4, 5. This is also a set A or S, you can call it. And this also is a set, same set. So we are picking a value A. In this case, I'm taking 3. We are taking a value 4, which is B actually. As B, we are taking 4. So just take the vertical and horizontal intersection point. This is 1, and which is the resultant. And please remember, 3 cap 4 or 3 operation 4 is equal to 1, and 1, 3, 4, they all are belonging to the same set. In any binary operation, we have different properties. So there are certain binary operation, and we need to have certain properties and types. So let us start one by one. Whichever you operate, 1 operate with 1, 1 operate with 2, 2 operate with 3, you're always getting certain value. For example, I'm just rounding now 3 operation 4. So all these values are coming from which set? Set is 1, 2, 3, 4, 5. So 2 values taken from the same set, the final value is also going to the same set, coming from the same set. So this is the closure property. So we have a set A which is in the row. This is also a set, same set which is in the column. And any 2 values picked up, the resultant value will also be from the same set. So it's a binary operation. Since it is shown in the tabular form, it is binary operation table. So I'm talking about the set S, which we have already discussed, 1, 2, 3, 4, 5. And this is the row, all the values are written in row and the column. And there will be the operation. Since all these values which you see in the table are from 1 to 5. So this is a closure property. Let us take the associative property. Take any value. Let us take A as 1, B as 2, C as 3. So I'm trying to show you the associative property. How does it work? So A is 1, B is 2, C is 3. Associative property means the operation should be like this. That is, when we associate, say, A operation, B operation, C, first we do B operation C resultant with the A, or we do A star B star C, first we do A star B, and then the resultant will be operated with C. So we are taking the values now, 1 cap, 2 cap, 3. So 1 cap, 2 cap, 3 is going to give you what? 2 cap 3. Okay. Now go to the table and see what is 2 cap 3 first. That is horizontal, you will take 2, vertical, you will take 3. So 2 from here, 3 from here, what is the resultant value? 1. So you are going to get 1. Now 1 was already there outside, so 1 cap 1 is what? 1, this 1, so the cap is 1. Okay, this is the first part. Now we'll take the second part. That is A star B star C. So 1 cap, 2 cap, 3. So first we'll do the 1 cap 2. So take 1 from the horizontal, 2 from the vertical. So 1, 2 is 1, resulting is 1. Outside we have 3, so 1 cap 3. 1 cap 3 is going to give you what? It's going to give you 1. So what do you get? 1. So in both the way you are getting 1, 1, so it is associative also. The next property we will try to ponder upon is the commutative property. So commutative means A cap B should be equal to B cap A. Okay, we are commuting, we are changing the position of A and B. So let us take A as 3, B as 4. You can take any value. I'm just taking A as 3, B as 4. So this is 3 from horizontal, 4 from vertical. The result is 1. B cap A. Now you take B as 4, A as 3. So horizontal you will take 4, vertical you will take 3. And what is the result here? 1. So in both the cases, you are going to get the result as 1. Right? So 3 cap 4, 4 cap 3 is 1. So the commutative property is also holding here. Next property is the identity element. Identity element, in order to find the identity element of a given operation, we need to find an element E or any I which satisfies the equation A operation E, in the case we are using operation as cap, equals A. So operation with any E should also give you the actual value. So if you see here, 1 cap 1 is 1, 2 cap 1 is also 1, 3 cap 1 is also 1, 4 cap 1 is also 1, 5 cap 1 is also 1. So 1, 2, 3, 4, 5, when you are doing cap or operation with 1, you are getting the original value. Or you can say you are getting the 1 value. So what do you get? This identity element is 1 here. 1 is the identity element. Then we have the inverse property. So in order to have the inverse property, we need to have the identity. So inverse property is all about showing a pair, A operation B and B operation A, when it gives you identity element or identity from the same set. A and B and E should be from the same set. So A cap B and B cap A is going to give you E. What does it mean? It means A and B are inverse pairs. A is inverse of B, B is inverse of A. Right? We already know that 1 is the identity of this particular table or this set. So 1 cap 2, 2 cap 1. 1 cap 2 is what? 1. And 2 cap 1 is also 1. 1 cap 2. You see from the table, 1 cap 2 and 2 cap 1. They both are 1. That means the 1 and 2 are the inverse of each other. You can also do 1 cap 3 and 3 cap 1. You will also see that this will also give you 1. And you can go on like that to actually confirm that inverse property actually hold, and this one was the identity and inverse property hold here.